Hi, welcome to this video. In this video I'm going to explain how I designed and built my infrared panel thermostat, which is programmed with the YAL programming language. So what will be the contents of this video? First, why I did this project. Then the main features of the infrared panel thermostat, the schematic diagram that I designed, the hardware that I built, then the main features of the software, a short demonstration video, and at the end you can find some references. So why did I do this project? I have an infrared panel below my desk and I wanted it to be temperature controlled instead of me switching it on and off. And I also wanted a device that switches the panel off automatically, so in case that I forgot to switch it off myself. And I'm using a PIC Microcontroller for this device, and I programmed it with the YAL programming language. So what are the main features of this infrared panel thermostat? Of course it does the temperature measurements, but it also does temperature regulation. And the measurement is done every 30 seconds. Then there is a timer function, and the temperature is programmable, and the range is between 10 degrees Celsius and 25 degrees Celsius, in steps of half degrees Celsius resolution. There is also a programmable timer, in the range of 30 minutes to 240 minutes, in steps of 15 minutes. And those values for the temperature and the timer are stored in non-volatile memory, so when you switch off the device and you switch it on again, it still remembers the previous settings. So the schematic diagram looks as follows. It starts with the microcontroller, which does all the work. And on the left I'm using a DS18B20 temperature sensor, which is capable of measuring temperatures in half degrees Celsius. Then there are two switches, one for turning the device up and one for down, but also for increasing and decreasing the temperature and the timer values. Then there is a display, which is multiplexed, as you can see by using the 3 transistors, so each display will be turned on one after each other. And I'm using a shift register, and this was to limit the number of pins that are needed to control the display. Then there's the relay, which will switch off and on the infrared panel. I have a fuse for safety, and I'm using an external power supply. So if you look at the hardware, it looks like this. So from top to bottom we start with the fuse, and also the power supply is connected to the fuse. Then we have the power supply, the relay for switching the panel on and off, the display and the transistors to control them individually, then the shift register and the microcontroller. And at the bottom you find the temperature sensor, and it is important to have it as far away from the power supply, because the power supply will get a little bit warm, and that may influence the temperature measurement. So the software is about 1528 bytes of ROM and 82 bytes of RAM, and the PIC microcontroller can handle this because it has 2 kilobytes of ROM and 128 bytes of RAM. And the main program does all the work, so it handles the switches, it does the temperature control and the temperature measurement and the timer functionality. And also some error checking is performed. For example, if the DS18B20 sensor is not present, then the display will show the error code E1. And if there's an error in the data that was received from the DS18B20, then the error code E2 will be displayed. And I'm only using one device file for the PIC microcontroller from the YAL open source community. And I did not use any other YAL libraries. And the reason was that I reused some software that I built in the past, and at that time I was not part of the YAL community. But there are some YAL libraries that I could have used, for example, a library for the DS18B20 and a library for the EEPROM. So in this demonstration video you will see the following. First I'm switching on the device and it will show the current temperature. Then I will increase the set temperature and then you will see the temperature control. So the infrared panel is turned on and you can also see that the LED will be turned on. Then I will change the set timer and I will decrease the set temperature again. And also then you can see that the infrared panel will be switched off and the LED will be switched off too. And at the end I will switch off the device. If you want to know more about YAL or about the YAL programming language, you can visit the YAL website. If you have questions on how to use YAL, there's a very good YAL tutorial that you can download. But you can also visit the YAL's Google group and post your question. If you find bugs in YAL libraries or in the YAL compiler, or you have specific requests for libraries, you can visit the YALib Google group. And all sources, including the YAL compiler, can be found on GitHub. I hope you liked this video and thanks for watching.